So let's go back to 4, 9. Here's my function, right? So I need to figure out what big ass f is, given this. Because big ass f is going to be the answer according to f top 2. So then how do you do something to the first power? How do you antiderive it?
Add 1.
Yeah, so it'd be 4 times add 1 and then divide by the new. Yeah. So that becomes 2x squared. The way I look at it is 4 has got a 2 times 2 in it, right? That 2 gets sucked back up. That's all. It just sucks the factor of 2 back up into the exponent, right? So if I was integrating, like, if f were 7x to the 8th power, big ass f wants to suck a 9 back up, right? So if you try to suck a 9 out of 7, it's going to go, no. 7 nice. Bam. I mean, that's a quicker way to think of it. But you can always just apply the rule. Add 1 to this and divide by that new number. That's the rule for any polynomial-looking thing.
Do you see that one in the right corner? Use that equation.
Where are we at?
I was just telling you to use that equation.
Oh, yeah, this one right here. Yeah. I like it. All right, let's do a couple more together, and then I got a little handout. Is that cool? Is that cool, Stephen?
That's great. Thank you.
Just trying to merge your name with the word cool. It's cool. All right, so what if I want this here? What like? So obviously, hopefully, just like derivatives, any root I must write as a fractional power. I like it, right? And plus, I'm getting way too many people. If I wrote this and I asked you to take the integral, you can't just take the integral of each piece. You can't even do that with derivatives. So if you can't do it with derivatives, you doubly can't do it with integrals. Because even the stuff you can do with derivatives, you can't do with integrals. The rules are not the same. But you can always do what first? What's one of my themes this semester? You can always simplify first. If you can do anything to simplify it, hell yeah. So this one I can just rewrite. It would look like what? Yeah. I like it. So now, the first step is really just kind of ignore this for a minute. I can just write it over here next to it. Use the rule on this bad boy.
So it's 3/4.
Yeah. So it's going to become 4/3. Divided by 4/3 this times 3/4. You did. And you see how these multiply to be 1? That's why there's a 1 there. If that comes down, it's going to make the 1 that's there. Right? You got to start thinking about integration in that way. It's backwards. If something would come out and it's not supposed to be there, kill it. Right? Stop it down. That's right. Kill it with fire. So now what do I do?
Just plug the numbers.
Just plug the numbers in. You plug the top one first always, because that's the bigger area.
Top first.
Exactly. Yeah, I like it. That's my song. See, it works somewhere else too. I didn't think about that. Thanks, Pop. 3/4 times 2 to the 4/3. Now here's another thing with this rule. It's always what here? Minus. Always minus. You're subtracting area, so you end up with the area in the middle. So this number might come out negative, which would make that positive, but that's the only reason it would be. So minus 3/4 times -4 to the 4/3. Now this is completely fine to throw in your calculator. You're not supposed to know what the cube root of 2 to the 4th power is. I don't know. I didn't get very far. You're waiting for me to do it. Don't wait for me to do it in my head. No.
-125/2.
What is it now? I'm getting two options.
I got negative.
I messed up.
Negative what?
2.87.
Negative 2.87 sounds better.
Yeah, I messed up.
How do you check this in your calculator?
Very careful.
Oh, I was like,
Put in the function and then do
Yeah, put in the function. And put that into y1. And then do second count, number 7. Right, it's got an interval thing built in. We've done it several times. Don't look at me like that. All you gotta do. Put it into y1. Second calc, second trace to get the calc. Number 7 is the interval. And then you can just tell it from -4 to 2. Check your work. It's crazy. Kick ass. Alright, let's try one more together, and then I'll unleash you guys on this handout. Well, nah, sure. Let's see. Do I want to? No, I don't want to do that. Alright, let's just do this. Yeah. It's gonna be crazy today. I like it. So, this is of course one of the functions we had a lot of trouble with, but what's the main part of this function is this guy. Where would this have come from? It would have come from this. That's a chain rule just screaming at you. I'm a chain rule. You can't integrate each piece. It doesn't make any sense. What an integral tries to do, and fails sometimes, is it tries to put things back together. Because what do derivatives do? They tear them apart. So that's one reason why we call it integrate. Putting it back together. Holy shit. The word means something. So you can't look at it like integrate each piece. You can't. Because this, if it was that is impossible. That's what's called a transcendental function. You can only represent this with an infinite sum. If you take Calc 2, you'll do this. It's awesome. It kicks so much ass. Thank God I put that there. All right. Now it's Calc 1 level. So if the antiderivative was this, why is it not quite right? Because the derivative of this would be 2x. So there's no 2 there, so there must be an over 2. Good right. Evaluated from 5 to 7. That wasn't that hard, right? So the main part of the function is normally pretty obvious to tell. It's like a root or an e or sine function or something, trig function. And the other piece is going to be some kind of polynomial, or it's going to be related to what's inside the other dude. So it could have very well had an x sine of x squared. It would have been exactly the same way. Except what's the antiderivative of sine? Negative cosine, kick ass. Alright, so how do you do this? You just e to the 49 minus over 2. E to the 25. 22, you're getting something crazy big.
9.5367 e to the
9.5.
637 e to the 20th.
Okay, times 10 to the 20. Kick ass. 637, right about this. Cool, I like it. I think they're doing Morse code from the other room. Hope they're okay, I don't know Morse code. Let's keep it to that. Alright. So here we go. I want you guys, this is not a quiz or anything, obviously, just to work together. Say that one.
It should be like 2x squared, right? And it's either one the 2x up on the top one, you do the other y.
Because I need, if it's not a 2 there, that must mean it died for some reason.
Oh yeah, and it should have to.
It was
so
killed
it's
back
basically
then.
one.
Yeah, I'm sorry. I could have written as 1/2.
No, you're good. That's how I always write it for myself.
Yeah.